Hello and welcome to this Touch tutorial. Today I'm going to be talking about integrating TouchDesigner with Eliza, which is an immersive audio platform from L-Acoustics. So what we're looking at right now is the Eliza controller. This is our window into the Eliza processor, and that is just a hardware unit that does all of the immersive audio processing. So this particular page is what is called our soundscape. So we have the listener in the middle, and then each one of these little circles with a number is what would be called a sound object. So that's something like a kick, snare, some bass, guitar, vocals, some sound effects. Now we don't hear any of this right now because I don't have a processor with me, so we're not actually running any audio through this. But if we were, and I just grabbed one of these objects, let's say a vocal, and I started moving this around the soundscape, we would hear this actually moving around us. So what I want to start thinking about is how do we take TouchDesigner and start making that control the behavior and the position of these objects. And there are a lot of different things that you could do with this, but one particular use case I'm thinking about is something like interactive audio, where perhaps we have a connect and we're tracking a player and we're using the movements of that player to generate positional data that we want to send out to sound objects to make the objects move in reaction to a player. So how do we go ahead, or how do we go about getting that data out of TouchDesigner and into Eliza? So I don't want to spend too much time inside of Eliza, but there are a few more things that I would like to look at. So first of all, if we come over to the Sources tab, just an overview, this is where I've set up my objects. So I've given them names, I've made some stereo pairs, I've given them a color. And if we scroll down, we see that there are 96 input objects available to us. So that'll be important. And then in control, and this is one of the most important parts for what we're doing, this is how we determine how we're going to control each object. So there are a few different ways to control them. One is with snapshots. This is an internal way of controlling them with snapshots right up here, basically like cues or scenes. We can also control them with plugins. So these are plugins for your DAW, like Logic or Ableton. And then we have external OSC, that's what we're going to be using. And then you also have the option to control them with trackers. That's something like Black Tracks, Posi StageNet, Stage Tracker, so on and so forth. And for each one, we can determine or specify particular parameters that we want to be controlled by each source. So for example, I could have the pan and width of my kick controlled by my snapshots, have the elevation controlled by the plugin, and the distance controlled by OSC. In this case, what I want to do is have everything, well, not everything, not the send, but the pan, width, depth, and elevation controlled by external OSC. So I'm going to go ahead and turn that on right now. And then if we come over into groups, groups are exactly what they sound like. They're just groups of input channels. So I've selected the drum group, and if I come down to my pan, I can pan all of them at once. I can also turn up the width, and the width is just kind of how much space the object takes up. I can also affect the distance. And in this case, we're not going to see any elevation because I don't have any overhead speakers, but this would move the elevation of all objects in tandem. You can control groups from OSC, and we'll look at that a little bit towards the end. If we come to the drop-down menu up here and go to Help, we are greeted with a nice HTML help file. And under References, we can come over to OSC API. And this gives us all the documentation that there is about the OSC API for ELISA controller. A couple of important things to note. Port 8880 is always going to be the receiving port for ELISA controller, so that's the port that we always want to send to. We also are able to send OSC out of ELISA controller to our external controllers or our external devices. So that's a little bit of information about that. We'll look at that briefly later. This is really what we're interested in right now to start off. Messages from external to controller. We start off here with control flags. So these are the control flags. We are able to change these via OSC, and that will come in handy. And then a little bit further down, this is these are the OSC messages for our source parameters. So today I'm mostly going to be interested in pan, width, depth, and elevation. All right, let's go ahead and move over to TouchDesigner. I'm going to start off by just making myself a base. And I'm going to call the base LTouch. And what I want this to do is just be a container for some custom parameters and for some code inside of it. So if I right click and go to Customize Component, I'm greeted with this customization panel, and right here I'm on custom parameters. So first I'm going to create a custom page, and I'm just going to call that ELISA. And then on that custom page, I'm going to make a few parameters. I'm going to start off with real time, which is going to be a toggle. Where's my toggle? There it is. Send, which will be a pulse. And what I'm after with this is I want to be able to either have a real-time connection between the parameters that I'm altering in TouchDesigner and the object parameters in ELISA controller, or be able to turn that off, adjust all of my parameters in TouchDesigner, and then just update them with a pulse. Really quick, real time, I'm going to make default on. Okay. Next parameter will be target. This is going to be a menu. It's going to have just two selections. So for the names, I'm going to have SRC and GRP. And then for the labels, which is what we'll actually see, I'm going to have source and group. Okay. So remember, in ELISA controller, I can either control these individual sources, or I can control whole groups. So that's what I want to indicate here. Now the label is source and group, but in the OSC string, it's actually going to be specified as SRC for source or GRP for group. And what I want to do is actually just grab that parameter name and insert it right into the OSC string. So that's why I'm doing that. For target, I'm also just going to turn on this section. Okay, and then I need an ID. This is going to be an integer. And this is the actual sound object ID. Default will be 1, min will be 1, and then the max is going to be 96. That's how many objects ELISA controller can handle. Perfect. And then from there on out, I'm just going to put in the 4 object parameters that I'm interested in right now. All of these are going to be floats. So pan, width, distance, elevation. Now all of these are 1 to 0, and that is a normalized scale that we're using with OSC. that is different from how they actually appear in Eliza controller. So pan is a measure of degrees, as is width. Distance is a measure of percentage. Elevation is also a measure of degrees. But when we send it over OSC, it's just going to be normalized 0 to 1. Okay, so these are all the parameters that I want to start with. So now I'm going to go inside of my base, and I'm going to create a parameter chop. And by default, it gives me just my custom parameters. That's exactly what I want. I do want to separate these out a little bit, so I'm going to get a select chop. This first one I'm going to call object parameters. And I'm just going to get my pan width, distance, and elevation. We paste that, and I'm going to call this real-time send. And I'm just going to get my real-time and send parameters. Now with this one, I want to reduce this to a single value, a single channel. I'm going to get my parent parameters really quickly, so I've always got this with me. And what I want that single value to be is 1 if real time is on, or if we get a send pulse, or 0 if neither of those things are true. I can do that with a logic OR. So I'll get a logic chop. And combine channels OR. So right now they're both 0, or right now that value is 0. If I turn real time on, I get a 1. If I have real time off, but I hit a send pulse, I still get a 1 for that pulse. I'm just going to rename that to true. Now I'm going to get a hold chop. And in the first input, I'm going to use the object parameters. And then this true value, I'm going to put in the second input. And what I want this to do is when I hit my send pulse, I want it to sample and hold all of the parameter values, or when I have real time on, I want it to be constantly updating and sampling these values. So, oh, let me fix one thing in my custom parameters. And I actually wanted to set the default to 0.5. Okay, great. So as I change these parameters, I'm not updating anything, but if I hit send, it'll update. Okay. And that's just the default behavior. So the sample parameter is off to on. And what that means is when there is a state change in the second input of going from off to on or 0 to 1, it will sample the first input. However, if I turn real time on, I'm not constantly sampling. I can change that behavior with this hold last toggle. But what is also going to happen is when I turn off real time, it will continue sampling. So the way I can fix that is simply by exporting this value to my hold last so that the hold last toggle is only turned on when I actually need it, which is when real time is on. Okay, perfect. That is the behavior that I've wanted. I'm just going to end this with a null. And then turn off the viewers for these. And now we can go ahead and move into DAT land. So the first thing I'm going to need is an OSC Out DAT. And up here in my parameters, network address localhost is fine. If you had TouchDesigner and a Lisa controller on two separate computers, for example, TouchDesigner is in Media World and Elisa controller is in Sound World, you'd want to get the Sound World computer IP address and put it in there. Port, remember, is always going to be 8880. And then local address, this is just for if you have multiple NICs on your computer and you want to send it out over a specified NIC. We don't have to worry about that here. Okay, and then I'm going to get a chop execute DAT. Value change is exactly what I'm going to use, so I'm going to leave that toggle on and then just edit contents. I'm just going to comment out all of that. Okay. So first, I'm going to set up a few variables. So OSC equals op OSC out 1. Target equals me.parent dot par dot target. Target ID equals me.parent dot par dot ID. Oh, and I forgot one thing. So actually up here, what I want to do is set up a dictionary. I'm going to call it paramdict. And what this dictionary is going to do is it's going to map these channel names to the OSC sub address corresponding to the object parameters. So basically what I mean is map pan to the string p, which is used to control our pan. So pan maps to p, width maps to w, distance maps to d, and elevation maps to e. Great. And then what I can say is param equals paramdict dot get channel dot name. So remember with this, TouchDesigner is essentially passing in the channel object that has been changed. So I can use the dot name function to look up its actual name and use that as a key to look up mapping in the dictionary that I've just created. Okay. Now what I want to do for this OSC message is really quite simple. I just put this down here. I'm going to copy and paste this in here. The one thing that's going to remain constant here is this ext. Everything else, I'm going to just programmatically insert. So source replace with curly brackets, curly brackets, curly brackets, dot format, target, so that will be source or group, target ID, that's the OSC ID that I'm actually targeting, and then param, that's P, W, D, or E. And then let's just go ahead and take a look at the Python API for this OSC Out DAT. I've got this send OSC method. It takes a number of possible arguments, but there are two required: the address, which is that string that we've just built, and then value list. So I'll say osc.send OSC message, and in brackets, val. And remember, this is the val of the channel that is being changed or being evaluated. that TouchDesigner is just passing along to us. Okay. So this should work. Let's go ahead and see if it does. So right now I'm on source ID 1. So let me just get that out. Okay, so pan works, width is working, distance works. We don't see elevation moving in the soundscape, but we can see the parameter down here. And if we change to something like 10, where's 10? Oh, there it is. So we can see that moving, width, distance, and elevation. Perfect. Also works with 12, right? Oh. Oh, why is 12 not working? Ah, okay. So 12 is part of a stereo pair. So let's try 11. There we go. So whenever you have a stereo pair, what you want to target is the what would be called left. It doesn't necessarily have to be on the left, but essentially the first one of the pair. So with overhead left and right, we would do object 3 to control that. So that's why that wasn't working. That's all well and good. Okay, so for the most part though, this is working properly. And if I turn off real time and alter all of these parameters and target, let's say 8, and then just pulse, there we go. Okay, so this is behaving very much the way that I want it to. Now, the next thing that I kind of want to look at is controlling groups and sources and being able to change between those two things. So if we come over to the Groups tab, I have, for this first group, drums, I have control turned on. And if I turn on my control flags, and I come over here, turn on group, V1, I'm able to control the entire group just fine. But what happens when I go back to source, and remember that object 1 is in this group 1, I no longer have control over it. Now, in the controller itself, in the Lisa controller itself, I can do that, but I don't have external control over it. And if we come over to our sources tab, we can see that all of the objects that are in that drum group, their control flags are darkened a little bit. So how can we fix that? As far as I can see, there's no way with OSC to change this control, to turn this on and off, but we can change the control flags individually. So if we come back over to the help file, so here's our OSC for changing control flags. As far as I can tell, it's only showing the OSC string for sources, but this does also work for groups. So what I'd like to do is just one little extra script where whenever we change to group, what it does is it turns on the control flags for the specified group. And when we go to source, it just turns those off and relinquishes control to the individual objects. So I'm going to go ahead and get a select. And I'm going to select out target. Now this isn't going to give us a string, but it will give us the index, which is still very much useful. I'm just going to call this target. And then I'm going to create a chop execute. Value change is what I want. I'm going to delete all of this out. Oops. Okay. So I'm going to set up some of my variables here. So OSC, we still need to target this OSC Out DAT. So OSC equals OSC Out 1. I'm going to need the target ID so I know which group to turn the control flags on and off for. Target ID equals me.parent.r.id. Now I'm going to make a list of parameters, and this is the list of the pars as they appear in the OSC string. Pars equals P, W, D, P. I'm going to make another list called flag states. And what this is going to be is just a two-item list, and it's going to be off and ext. And the order of these are important because we're going to match up the index of the item to the index of the target parameter. And then flag equals flag states int val. So the val that is being passed to us is the index of the target selection. And we just want to make sure that we make that an integer, because even though that is either 0 or 1, any value inside of a chop is always going to be evaluated as a float. And because we're using it as an index, we just want to make sure that it's actually an integer. Okay, so now, since we have this pars list, what we can say is for par in pars, message equals text flag group curly bracket dot format target ID par. And then I'll say OSC dot send OSC message flag. Okay. So no errors. Let's see if it works in here. Cool. Okay, so we got something right there. Whenever we switch to group and it's group 1, it goes ahead and changes the control flags. And then we have control over group 1. Now if we go back to source, I have control over the individual sources in that group. Perfect. Okay, so a couple of other things that we'll look at is how do we get feedback from Eliza, right? So source right here, as I'm changing the position of object 1 within Eliza controller, how do I get this to update in my parameters here? so that I don't have something, oops, I don't have something like this where the object is jumping around as I go back and forth, as well as looking at extensions that we can write for this LTouch base comp, so we can actually attach custom members and custom dictionaries and custom functions to this base component itself. That will come in a later tutorial. For now, I think we're at a pretty good stopping point. And this is really, it's actually fairly simple. This is not a very complex network. Even the Python that's involved is fairly basic Python, and yet it can be very, very powerful when paired with something like Connect or Leap Motion or some sort of other generative data within TouchDesigner. So until next time, thanks for watching.